Right, so today we move on to our next subject first, that is data management system. Okay, uh, data management system. So today we want to do the first topic and possibly finish it. That is data management evolution. First, I will show you the syllabus. So then straight away we'll move on to the first topic. You have only 5 topics there. Data management system. So this is continuation of your semester 2 subject. Database systems. Okay, database management system. So this is just a continuation, though they have given you a different name. Uh, right. So in this subject, something like the database two. So we look at some more aspects of databases. Remember, in semester 2, we concentrated on relational databases. Right, analyze and model like ER modeling, then design, primary key, foreign key, right? Designing one-to-one, one-to-many, many-to-many, unary, binary, ternary relationships, primary key, foreign key. So we have done those things. Okay. Mapping weak entities, mapping inheritance, when it is total, partial, when it is overlapping, disjoint, and also we have discussed normalization, first normal form, second normal form, third normal form. And also we discuss SQL, how to query with write queries, create tables, alter, drop, and then query, insert, update, delete, and select. And also we discuss bit of views, bit of security, how to grant access. So it's a huge thing, syllabus we have covered. Right. So here we continue from where we stopped. Continue from where we stopped. So we are in this subject, data management system. We are remember the 3T architecture, external or user tier, logical or conceptual tier, physical law, internal tier. So last semester we were more in this tier. But this semester we will spend more here. That is where you have the index and tuning. Okay, and also a bit of constraints and triggers. Right. So that is your second topic and third topic, constraints and triggers. Okay, and database indexes and tuning. We are into the physical tier, performance optimization and so on, and some more control. So our first topic is, remember, say, semester 2, we were 100% concentrating on relational databases. But we have some other database management systems like object-oriented, NoSQL. Right? So in topic 1, we will be concentrating on other database management systems than relational. Okay. So that is what we are going to do today. And topic number 4 is distributed databases. That is where your database is distributed among different machines. Some tables are in this machine, some tables are in that machine. Maybe these are far away in different countries. Maybe employee table here, department table here. Okay. So that is distributed database and management systems. And still it's act like a one database. And the fifth one is consistency, transaction processings. So it's all about how to handle transactions. Okay. So this subject is fairly difficult subject. Actually, this subject was in the final year. And about 3 years ago, they took it from final year to semester 3. Right? Final year to, that is semester 6 to semester 3. But most of the syllabus is as it is. About 20 to 30% of the syllabus they removed because it is too much and too advanced for someone in semester 3. But more than 70% of the content from the final year, they take it to the semester 3. Okay. Therefore, this is very tough subject. Uh, unless you understand, think in deep level, serious understanding, you won't understand this. You can't just now remember when it comes to some semester two subjects, right? Like HTML, you just remember those tags, right? You just remember those tags. But this is not like that. Even SQL, you need to think a bit, but not very challenging. But here, challenge is much bigger. Challenge is much, much bigger, especially when it comes to transaction handling, okay, indexing, database systems, distributed databases. Right? So you need to think extra hard, extra depth. You need to go to extra depth to understand. Otherwise, you will not be able to understand. If you don't understand, now the vicious cycle start. You start try to memorize things that you don't understand. It doesn't work. Okay, right. So therefore, this is the toughest subject in semester three. Right. This is the toughest subject. Right. Right. So let's start our first topic: data management evolution. Okay. So for this topic, I have given you our note. Sorry, I have not given you our note. I have given you only the UCSC note, but it has been highlighted. And small supplementary note on MongoDB and a link related to column store, column family databases. Okay, so just about 10 minutes recording video. So I will be using UCSC note, highlighted UCSC note. Okay, right. So you can download the highlighted UCSC note and follow it. Okay, and you can take bit of notes where necessary. And also, if anything is not clear, make sure you ask questions and get it clarified then and there. That is the best thing you can do rather than you keep collecting doubts. Okay, right. Data management evolution. Actually, this is the easiest topic in this subject. Right. So this lesson on data management evolution uh, discusses the gradual development of management of data, obviously, right? Evolution. So here we look at object databases, XML databases, NoSQL databases, and some more different type of databases. You can see no relational databases because we have covered that. Okay, and also we want to compare between these databases also compared with relational databases, right? Process, cons, when to use object database, when to use XML, when to use NoSQL. Okay. And describe how and why different data management techniques evolved. Okay. Identify requirements for object databases. Explain the key concepts in OOP. That is, of course, we have already done. So therefore, that part we can do very fast. Recognize the importance of NoSQL database. Describe different data models available in NoSQL. Within NoSQL, the data models. And analyze difference between NoSQL and relational databases. Remember, we have already worked with NoSQL databases under web development 1. So we connected to the Node.js, my NoSQL using Node.js. But there we just had a quick look at NoSQL or MongoDB, right? So this time we are going to look at it a little bit more in detail, but not much details. But we are going to do a small revision. Okay. So you must already having familiarity with the NoSQL or the MongoDB database. Okay. Because we did that in semester 2 with practical. Actually, we not only communicate, work with the MongoDB directly. We even communicate with Node.js, right? Connecting to MongoDB through Node.js. Okay. Right. So these are subtopics. Right. Major concepts of object-oriented XML and NoSQL databases. So then more theory about object databases, then XML databases, and then NoSQL databases. Okay. Then some comparisons and so on. Okay. Right. Object databases. Remember the idea behind relational databases. Remember the databases evolve, right? So we discussed that in semester 2. Network data, hierarchical databases. So then network databases, then relational, then object oriented, NoSQL. And of course, in between, we have the object relational also. Okay. So hierarchical develops the database or design the database as a strict hierarchy, which is too much constraints, too many restrictions, not flexible. So then try the other extreme, network databases. A lot of flexibility, but no control. It's a mess. So then settle for the relational databases. It's not as rigid as hierarchical, but at the same time, not as messy as network. It's a right amount of control and flexibility. And also it is based on relational theory. And for very long period, relational databases dominated from 1980s to 2010, 2000, even 2020. So relational databases dominated. Okay. So then somewhere around 2000, object-oriented databases also came into the picture. Okay. But it has some limited usages. It has not completely replaced relational. And also somewhere around 2020, NoSQL databases, of course, NoSQL databases came before 2020, but start some significant dominance in somewhere around 2020. NoSQL databases. So therefore, these days we use mixture of relational databases, object-oriented databases, and NoSQL databases. Okay. And sometimes we use object-oriented programs connect to relational databases through object relational mapping also. Okay. Right. So we'll first look at, of course, relational databases we have already discussed. We are not going to look at it again. Okay. So we will first look at object-oriented databases. Right. So why do we need object-oriented databases? Because we heavily use object-oriented programming. So remember, up to around 1990s, or latter part of 1980s, software development was 100% structured base. But latter part of 1980s and early part of 1990s, software development, we start doing object-oriented also. Structured, object-oriented. But by that time, we only had relational databases because this pick up in 1990s. But relational databases evolved somewhere 1980s. So then we continued to use relational databases and object-oriented programming. So pretty soon they found, software engineers found, so there's a mismatch. Database is relational, software programming part is object-oriented. So as a solution, they start thinking about object-oriented databases. Okay. And as an intermediate solution, they came up with object relational databases like hybrid. And also object relational mapping, mapping your classes to relational tables or relations. So those are different solutions. But the ultimate solution or ultimate good thing can be object-oriented programming, object-oriented database. Okay. So therefore, object-oriented databases are still evolving, right? Still evolving, and object-oriented databases have not replaced relational databases. Rather, there's a niche market for object-oriented databases. But others, they are still happy to use relational databases or object relational databases or doing some mapping. And of course, because NoSQL database has popularized, a lot of people use NoSQL also rather than direct object oriented. So they had moved from relational to NoSQL rather than relational to object oriented. Okay. Right. So now you know why there's a concept called object oriented databases. And it is still evolving. So therefore, actually, we don't have serious object oriented databases. All the object oriented databases are still evolving. Okay. So therefore, in our sessions, we will only look at the theory. We will not do a practical session because there's no dominant object-oriented database right now. Okay. So we have dominant NoSQL, like MongoDB. We have dominant relational databases like NoSQL, Oracle, but there's nothing called dominant object-oriented database. So that is another reason why people use less object-oriented databases. But this is evolving. And also we can use bit of object-oriented in NoSQL also. So therefore, we are going to look at the theory part. Theory part. And the theory part is pretty easy because we have already done object-oriented programming in semester 1. And also we did a revision in object-oriented designing through last 2 weeks as part of our object-oriented analysis and design. So therefore, I'm going to do it very fast. Right, you know the basic idea behind object-oriented programming is we look at the software as set of objects that communicate and collaborate. So the basic concepts are the concept called object, the concept called class, of course, the attributes and behaviors, messaging between objects, association, relationship, inheritance, abstraction, encapsulation, polymorphism. Okay, so we have done the discussion revision in previous 2 weeks as well. So therefore, I'm not going to look at those things again. If anyone missed those sessions, so you need to go through the recordings. Okay, right. Now the idea is in programming, say Java, C++, we work with classes and we create objects. Right? And one object call behaviors of another object. We can have object class hierarchies. Savings account extend from account. Right? And so on. So now we look at how can we apply those concepts to the database side. Okay. Right. So we have already discussed about uh, the evolution, especially with C++, Java, latter part of 1980s and early part of 1990s. So the object-oriented software development pick up. So these are some of the object-oriented databases. Most of the time, you may not have heard of these things. These are not big databases. These databases have very small niche market. Okay. Orion systems, Gemstone.
What is the niche market?
Niche market means only small markets, only selected customers. It's not a general market. It's a marketing term, right? Business term. Right. So therefore, these are not very popular, but some projects they use. Right. Some project they use. But for the exams, you need to remember these names, right? Orion, gemstones, and so on. Okay. Some of these are open source, some of these are commercial. Right. So I'm not going to repeat those things, right? So remember the concept of object. Object is anything that we are interested. It can be living physical things like customer, student. It can be non-living physical thing like machine, goods, product item. Or it can be conceptual thing like account, course, appointment. And remember, we are interested in two things about objects or classes later. That is attributes and behaviors. Another name for attribute is state. Another name for behavior is service or operation. Remember, when it comes to programming, attributes become instance variables or class variables. Behaviors become instance methods or class methods. Okay. Right. So now we look at those things in little bit in the context of databases as well. Persistence. Okay, saving. Now, when it comes to objects, we can remember objects are created using class. So what is a class? So class models similar objects. To represent all account objects, we have account class. To represent all the customer objects, we have the customer class. So what do we model? We model attributes and behaviors. So what is the use of class? At runtime, we can create objects from that class. From account class, we can create account objects. From customer class, we can create customer objects. And then we look at the system as these objects communicate and collaborate with each other in the system. Okay. So that is how we look at object-oriented software. Okay. So do you have any questions about that part? Because we have covered that revision. Okay. What is a class? What is an object? What is attribute? What is behavior? Right? What is messaging? Right. And remember, there's a connection between class and object. Class and object are two different things. Class is the blueprint or the factory where we have modeled the attributes and behaviors. Why? Because we can create objects out of that class. For example, when you go and enter your bank card to the ATM machine and enter, so then account object is created, customer object is created. First, the customer object is created because then only it can check your PIN number. Your object is communicating with the database. Then when you select the account object is created in the server, not in that time machine server, web server or application server. So, so then it retrieve account, that particular account related data from the database. Now these objects need to communicate with the database tables. Current context, yes. Say account object communicate with account table. Customer object communicate with customer table. But in object-oriented databases, the idea is rather than account object communicate with account table, so can't we have account object in the database? Can't we have customer object saved in the database? Okay. So that is the ideal thing, right? So then no mismatch. Programming side also account object, database also we have account object. We save account objects, not account record. We save customer object, not customer record. Okay, that is the idea. Right. So when it comes to objects, we can identify two type of objects. What are those? Transient objects and persistent objects. So persistent object means we want to save that object. So there's a connection between that object in the program, and if you have object-oriented database, there's object, okay, in the database. Or if you look at traditional relational database, there's a record corresponding to that object. So then we say it's a persistent object because it has a connect, it has some persistence means save. So there's a corresponding object or record in the database for that object. So if you have a corresponding record or object in the database, record means if it is a relational database, object means if it is an object-oriented database. So then that object is a persistent object. But there can be some objects we create to do some validations and any other control actions and so on, but there is no corresponding object or record in the database for that particular object. That particular object is in your program, say Java object, PHP object or whatever, but there's no corresponding record in the table or corresponding object in the table or database. So that kind of objects are called transient objects. Okay. So now you must be able to think about what are the possible examples for transient objects in a software program. What are the possible examples for persistent object? Okay. Say you are doing some validation, right? Some validation, object-oriented manner. So then you create that validate object and do the validation. Is it a transient object or persistent object? Anyone? That validate object.
Transient.
It's a transient object because that validation is done. There's nothing called, you save that validation, right? That validation is shown to the user and that's it. And user will take an action. So that kind of, then UI related objects like your form objects and blah, 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 database connectivity objects. So those are transient objects. There's no corresponding record or object in the database. But there are plenty of persistent objects. So those are basically your domain objects. Customer, account, payment, order. So whenever there's an order, there must be order record, order object in this database. Payment, there's a payment record, payment object. Customer, customer object, customer record. So those are persistent objects. So that is the first thing you need to understand, whether a particular record is or object is a transient object or persistent object. Because not every object is a persistent object. Because in object oriented programming, everything is object. Okay. Even UI button is object, J button, J form. But you don't save a J form, right? Maybe you save a new customer object. Okay. Right. So when it comes to objects, remember objects have objects encapsulates attributes and behaviors. So that we discussed in the last class also. Right. Object encapsulates attributes, behaviors. Say count object. Right. Account object. Account number, balance, behaviors, deposit, withdraw, add interest. So out of these, what do we save? Say if it is a persistent object, we save the attributes. We want to save the account number, right? Balance or updated balance. Behaviors are nothing to do with saving, right? Because you don't save deposit method, right? You don't save withdraw method. So your database objects or database record is related to attributes, not related to behaviors. Okay. especially if it is a relational database, because in relational databases, you just save the attributes. There's nothing called, if it is object-oriented databases, or object database, yes, possibly we can think about these things also in the database, because we save object. If it is object, yes, there's a possibility of behaviors. But if it is a relational database, obviously we forget about the behaviors, we just save the attributes. Again, not every attribute, if it is stored attribute. Remember stored attribute, derived attributes. Not every object is saved. Only persistence objects are saved. And again, not every attribute is saved, right? Only stored attributes are saved. And if it is relational database, you don't care about the behaviors. But if it is object-oriented database, maybe we can think about the behaviors also because we save objects, right? Right. So then what is mean by object identifier? Object identifier is a special attribute that uniquely identify object. It is corresponding to in relational databases primary key. Remember every table must have primary key field. So then every object must have identifier. For example, account object, account number, student object, student number, customer object, customer ID, payment object, payment ID. So that is called identifier attribute or object identifier. Ideally, it must be system generated. Remember in semester 2, I told you that surrogated primary keys are better. Surrogated means system generated. So this object ID in object databases rather than primary key, we call it object ID. And ideally, object ID must be machine generated, surrogated. Okay. And also, most of the time, this object ID is hidden to the users because it's something to do with the system. So don't think that your object ID is account number. Don't think that your object ID is student registration number. No, student registration number, account number, yeah, those are there. Unique fields. But they are not identifiers. Ideally, identifier must be machine generated object identity. Okay. And other fields must be just fields, unique fields. Right. What are the features of an object identifier? These are same as features of a primary key. Right. In object-oriented databases, we call it object identifier. Obviously, object identifier must be unique. Right. No two objects must have the same, can have the same identifier value. And also it must be immutable. That means it must not get changed in the life cycle of that object. Okay. So you are not supposed to change the employee now ID, student ID, bank of account number, or the machine generated identifier corresponding to that object. Okay. So OID is pretty much similar to the primary key. Okay. Or pretty much similar if you have a surrogated primary key. Right. So now we have discussed what is an object, right? What is attributes and behaviors, and also what is object identifier. Features of a object identifier. Right. So the next concept is literals. Right. Literals. So literals are different from objects. Literals are also like objects, but not objects. Okay. So literals are pretty much like structures in programming languages. So literals do not have an object identifier. And literals, we don't save it as a unique object or unique record. Okay, so literals are pretty much possible values. Possible values. So therefore, literals are used as data type for attributes of your objects. Like gender is male or female. Credit card type is Visa, MasterCard, Amex, and so on. So those are literals. Okay. So literals are embedded inside objects as a value for a field, right? So therefore, as an object, a literal doesn't have big meaning. Okay. So there's no big meaning for male object, but gender can be male or female out of. So the literal will define what are the possible values. So literals can be, because literals we need in object-oriented programming and also then object-oriented databases. So we can classify literals into few types. Single value to atomic types. Okay. It's something like male, female, one of the value, or MasterCard or credit Visa. It can be either MasterCard or Visa. So we call them single value to atomic because it's only one value is assigned, right? If it is MasterCard, MasterCard. If it is Visa, it's Visa. If it is male, male. Single value to atomic literals. Or it can be structured literal. Okay. So that means its set of data is saved for that field, set of data. Right? Maybe address. So address has number, street, city. It's a structure. So that literally is a structure. But there's literally is atomic value like M of F, MasterCard, Do, Visa. Third possibility is your literal can be a collection. So that means your literal has set of values like contact numbers. So maybe you have that particular employee has three contact numbers. Say language skills. Maybe particular person can have multiple language skills. Collections. So what are the possibilities for literal? Single value, structure, collection. And these are some examples for single valued literals. Single valued to atomic literals. Like first name. It's just a string. Gender, just maybe a chart. Salary. So then what about structure or tuple literals? So your literal can have several components of maybe different data types also, right? Like employee name. So it consists of first name, middle name, and last name. It's a structure. Look at this syntax also. This is pseudo. This is not a particular database language because we are not bound to an object database system. We just look at it as a pseudocode, pseudo query languages, and so on. Okay, right? Struct your literal name, field name, so literal name, and what are the literal values, structural values. So therefore, if you have employee name as a field, its type can be empty name. So then it can have three possible components: Nimal, KD, Pereira. Okay, so this is single value literal or atomic literal, structure literal. So then there's a possibility of collections. Collections. Collection means multivalued. Right. So the collections can be two types: static, dynamic. So static means it's not growable. So at the beginning, you decide what is the maximum number of elements. But dynamic means it's growable. Dynamically, you can add, remove, growable. Okay. So when it comes to dynamic collections or multi-valued concepts, so we can have set, bag, and list. Set, bag, and list. Under static collections, we have arrays. Okay. So dynamic means growable. You don't pre-specify the size. So then and there, I take the current size. Dynamically, I'll pre-allocate memory. It's flexible, right? So how many dynamic collections are there? Set, bag, list. So why do we have three? Because these three have different features. And depending on our data, we can best pick whichever we want. Right. If it is set, that means it is unordered and also no duplicate allowed. And obviously dynamic. Unordered, that means order is not maintained and duplicates are not allowed. And dynamic, you can dynamically add. If it is a bag collection, again dynamic, but this time it is unordered but duplicate allows, like putting it to a bag. You can add the same type of data twice into a bag. It's not rejected. So dynamic, unordered, duplicates allowed. Set, dynamic, unordered, duplicates not allowed. And third one is list. So list is again dynamic, this time ordered, and duplicates allowed. So duplicates are not allowed only in sets. Dynamic, ordered, duplicates allowed. So those are the dynamic collections. So then you have static collection called array. So array is always size is fixed. And most of the time data type is also fixed. But in some cases type can be dynamic. And obviously this is ordered. That is why we access it using index, zeroth element, first element, second element. Right. Another collection is dictionary. So dictionary is pretty much like map in Java. So far, either we don't have an index or our index is 0, 1, 2, 3. For example, set you don't have index, but list 0, 1, 2, 3 index, especially in Java. So then we have dictionary data structure. It's again dynamic collection. So this time we decide the key. It's like map in Java. We decide the key and value. Say rainfall, Colombo, 120 millimeters. Okay. So that is called dictionaries, key value pair, which is very handy when we work with this kind of data. Otherwise, you need to keep track of what is your zeroth index element, first index element, and so on, right? Right. Any questions up to this point? Anything that you have doubts? Right. After the break, we'll look at how to define your classes, structures, and so on. Okay. And also inheritance. Right. So now it is 8:50. We'll start at 9:10. So now we have discussed that there are two types of objects: transient objects, persistent objects, and also the difference between object and structure, and also what are the different type of collections: dynamic collections like list, bag, uh, set, and dictionary, static collections like array. Right. So how do you define it? Again, we use pseudocode, right? So this is not real object-oriented database language. Right. Of course, we can't use SQL because SQL is for relational databases. So this is pseudo language. Let's assume there's an object-oriented database, and this is the language we use. So remember, there's nothing called tables, right? But you can have types. So there's small differences. So therefore, you need to pay attention, right? So there's something called type, right? There's something called tuple. Right? There's something called tuple, and there's something called class. Right? Type, tuple, class. Okay, so let's start with type. So type is like relational table, but it's not relational table as well. So the main difference between type and class is class can have behaviors, whereas type have only attributes, right? Type can have only attributes, no behaviors. If you want to model behaviors also, that means your database object has bit of behaviors also, then it must be a class. So your type is mapped to a particular entity, department entity, student entity, payment entity. But you can't have behaviors, only the attributes. That attribute can be simple attribute, or it can be a collection, structure. Okay. So here you can say department entity or department type has a tuple. Almost all the time your type is a tuple. And each element can be atomic, like string, integer, or it can be again tuple or collection. Your attribute can be atomic type, or your attribute can also be a tuple, or your attribute can be collections like set, list, bag, map, sorry, dictionary. Okay. Always your type is initially tuple. Okay. Tuple. So you can understand why this is string, right? Because department name is a string. Department number is integer. Say department location is a string. So then you should be able to understand why do you have these collections, because these are relationships. Department has multiple locations. Say that department has is maybe it has branches in Colombo, Candian, but Batiklo. So these are the employees. So the department has many employees. So there's nothing called relationships. So these are associations. Remember, class can have association with another class, bidirectional or unidirectional. This is unidirectional, right? So this is bidirectional. Say department that has employees, one to many. Department can have many employees. Employee belong to one department. So then your employees is a set of employee type. Now the data type is another type, which you need to define separately. Just like this, you need to define what is employee. It may have its own tuple with own atomic attributes and maybe another collections, another tuples and so on. Okay. So if it is many side, many association, you have collection. If it is one association, like department can have one manager, so then it's a tuple. One association means tuple. Many association means collection. Or if it is an atomic attribute, go for string, integer, or whatever. Okay. So this means department has one-to-one relationship with manager and one-to-many relationship with locations, employees, and projects. And department has atomic attributes, department name, and department number. And possibly department number is your identifier. But remember, object identifier is usually machine generated, right? If anything is not clear, you need to ask, okay? Right, you need to do these exercises. I am not going to do these exercises. Uh, if you want to double check the answers, just put it into ChatGPT. ChatGPT will tell you the answers. Okay, right. So you just take a screenshot and put it to ChatGPT and ask what are the best answers for the blanks. So ChatGPT will give you the answers. Okay, and 99.99 answers are correct. Right. So any questions up to this point? Right. So if you don't have any questions, we'll move on to few more concepts related to object-oriented databases. Right. Encapsulation. Remember we discussed about encapsulation last classes also and object-oriented analysis and design. So objects encapsulates attributes and behaviors. Right. Object encapsulate attributes and behaviors, both attributes and behaviors. So encapsulation is a put it into structure. So far, our object has only attributes, no behaviors. That is why we use a type, not a class. But if you want to encapsulate behaviors also into your object, so then it will be a class. It will be a class. And now you are going to have some behaviors also. Okay. And when you encapsulate, remember there's a special case of encapsulation called what? Data hiding. So we have covered those things. We discussed those things in the last 2 weeks. So there's a special case of encapsulation called data hiding. So that means you hide your data. Other object cannot access your data directly. Those are private, hidden. And if you want to access those data, you need to call the behavior. Okay. So then your private attributes will get the data. Like say count class, balance is private, hidden. If you want to change the balance, you must call the deposit behavior, withdraw behavior. And of course, there can be some non-private attributes if you want to directly access that attribute. So then we say that it is properly encapsulated and even data hiding is also done. Right. So when you encapsulate, the result is a class. Okay. So class can have both attributes and behaviors. But remember, the persistence ID is more related to attributes. Persistence, because database is all about data, not behaviors. Still, we can define your behaviors and let implementation done by your programming languages. Because there's nothing called implementing deposit behavior in your database. But it makes sense to have account number field, account has a customer, account has a balance, but it doesn't make sense add interest, deposit, withdraw. But still we can model those because we are having a object-oriented database. So we want to closely relate your database and software programs. So if your program has objects, classes, so why don't we have classes in our database also and let behaviors handled mostly by database, programs. Okay. So remember your class can have attributes, behaviors, and even constructor, destructor. Okay. But constructor destructors are more related to the programming. Then getters and setters. Setters are called object modifiers. Getters are called retrievers. Another name, right? Another name for getter is retriever. Another name for setter is modifier, object modifier. So if someone talk about object modifier, that means setter. Someone talk about object retriever, that is a getter behavior. Basically, that getter will get attribute, private attribute. Right. So now we have extend our concept into a class. Now it is not a type, rather class. Earlier, define type department. Right? Define type department. But this time, define class department. So this part is still there as it is. Right? So your department is a class now, and it has a tuple, department name, which is atomic, department number atomic, department has a manager, therefore it's a tuple. Okay. Locations, which is a collection, employees collection, a projects collection. So that means department has set of employees, set of projects, and departments is in the set of locations. So this is a set of primitive type, atomic type, but this is a set of another class or another class or another type. It depends on how you define your employee and project. So if this is a class, most probably these are also classes. And now this is a class. So now you can have operations. Earlier, no operations because earlier it was a type. Now it's a class. So you can have operations. Okay. Behaviors. Your behaviors can be something like create department, delete department, right? Assign employee, that is assign employee to the department, remove employee from department, something related. And even it can be getters or setters, like number of employees. So that means get number of employees. Right? But you just specify the attribute. But if you specify the attribute under operation, that is a getter method. That is a getter method. Okay. But these are natural behaviors for the department class. Adding, assigning employee, removing an employee, and creating a department. It's like constructor. Now you can see it's like a class, attributes and behaviors, but there are a little bit of restrictions as well. This is another example. Student class. So student class has the type tuple. Almost all the time, whenever you have class, you have type tuple. First name, last name, NIC, date of birth, address, gender. Then student is associated with a department. Maybe this is another class. So then these are getters, get age, because these are though we save it, you don't have direct access to these fields if it is properly encapsulated and data hidden. So then you need the get age method to access the age. So maybe constructors like create student, destroy student. Okay. Okay. Right. So this is what you get in the exams. They will give you a scenario and ask you to create a class. Create a class for corresponding to that. Okay. Right. So we already discussed about the persistence objects and transient objects. Transient objects, there's nothing in the database. So therefore, for transient objects, there won't be any classes like this in the database, like validations and so on, UI forms. But domain objects, you have the classes or types in your database, object-oriented database. Okay. And also persistent object has object identifier so that we can uniquely identify object of that class. Right. How do you persist a persistent object? Now, this is a very important concept. How do you persist a persistent object? Like persistent object is something like order, customer, employee. So these are the two mechanisms. You can persist by name, persist by reachability. So remember when you create an object, you get a reference variable, right? Say student S1 equal new student. Say Java. So then if you use this reference variable and says S1, say you set the properties and so on, right? Now you have the student details. So now if you say S1.save or something and use that to save your object, persist your object, you can see that you are using that reference name, object reference or name of the object reference. So that is called you persist using the name. You directly save your student object. Actually, this is now you are saving to the database. Okay. That is called persistence by name or object reference. Okay. Second approach is persistence by reachability. So in that case, what happens? For example, let's say student has, okay, let's take account example. So department example. Now, when a department is saved, right? So if you need to save the department name, department number, Sometimes, first time when you save the department, maybe you have already assigned a manager. Maybe you have already assigned locations, or you already assigned set of employees. So that means when you save your department, you save the department by reference, but already you have set some projects, employees, manager. So then when actually you are saving the department, but when you save department, your database know that there's a manager, there are a set of employees, possibly. If so then it is automatically saved. If you have set those employees, projects, and so on, but you just save the department. So then we say that you persist by reference. You save the department, but at the same time, in the background, you save some employees or related employees for the department and so on. Set of locations, right? So that is called reachability, persistence by reachability. Not only saving, even loading, right? Say you retrieve an object of department. So then when you retrieve that object to your program, if you have object database, it will not only retrieve your department, it will retrieve all the locations of the department, all the employees of the department, all the project of the department, because in the background that you can specify whether if there's something called lazy loading, eager loading. Lazy loading means only department is loaded. You just wait, your database just wait, uh, load in the employees, projects, and see whether you access it. That is called lazy loading. But there are situations you can configure whether it's lazy loading or eager. So if it is eager loading, when department is loaded, at the same times the project's employees are also loaded. Okay. So therefore, this reachability is not only for saving, even retrieve, update. So when you update, not only you update the department details. So if you have updated employees and so on, those are also updated. Okay. So this is not only in database, object-oriented database. So this concept is there's something called object relational mapping. Your database is relational database like Oracle, MySQL. Your program is object-oriented like Java. So then there's a technology called object relational mapping, Hibernate, Java Persistence API. So using those technologies also you can do the same. But that is not object-oriented database, relational database. So then also when we can configure so that when we save the department, you save related employees and so on. So reachability. When you load department, you load employees also. Or you can say just load the department, don't load the employees unless we access it. So therefore, this concept of reachability is not only in object-oriented databases, it's even in the object relational mapping frameworks like Hibernate, JPA, and so on. Okay. So I told you this is serious stuff, right? You need serious thinking to understand this. And not only that, this is something that software developers implement. If you are a software developer, Java developer, you ask from any software developer who is doing Java development, they will say, yes, we are using Java Persistence API, JPA. Even final year student, you ask if they are using something like uh, Laravel, most probably they use object relational mapping frameworks. Okay. So if you search for something like, okay, rather than searching, let's ask from ChatGPT. Explain ORM device that. in Laravel using code example. You can see table is mapped to the class, so model, row is object. So you can see this is you are creating, setting the attributes, and then you just save it. Right. So this insert will happen by the framework. You just call the save method. When you just call the save method, and if you have done the mapping to the table, the related table is new record is inserted. And retrieve, you just call of all find additional where conditions, so then you get the data. Okay. So similarly, you can ask it to JPA example. That is Java. So pretty much the similar. You can see student. So this is the object identifier. It's a generated value, surrogated key. So these are the email field is mapped to. It's a persistent field. Okay. You can see getters and setters. Okay. Right. So this is just the ABC of that concept. Okay. But that is of course not object databases. That is object relational mapping. But this is if you rather than mapping, you straight away have an object database. Okay. Right. So that is reachability by naming or object reference. Or when you say a particular object, the related objects are also saved. Or when you retrieve a particular object, related objects are also retrieved. That is reachability mechanism. This is naming mechanism. Reachability means because it's associated object, that is also retrieved, that is also saved, that is also updated. Okay. So making the object reachable from some other persistence object. An object B is said to be reachable from an object A if a sequence of references to the database lead from object A to object B. So when you say customer object, maybe you say both customer and odd objects related to that customer. Okay. Right. So we already discussed about defining a class and adding some operations to that. Okay. Other than your tuple may refer to other tuples or collections of tuples or atomic values. Right. Another concept in object-oriented databases is what? Inheritance. Inheritance. So inheritance is creating a hierarchy of classes so that classes below the hierarchy get some attributes and behaviors from the classes or non-private attributes and behaviors of the super types. Okay. So you inherit both attributes and behaviors, non-private. Of course, behaviors are more related to the program rather than the database. Right. මේව මම ආයි කතා කරන්න ඕනේ නේද දන්නවද? Subtype, supertype. So this is in our pseudo object-oriented database language. This is how you specify inheritance. Say employee is a special case of person class. Okay. You can see employee is a subtype of person. Student is a subtype of person. Person already has some attributes. Maybe it has some behaviors also. But employee type class is going to add some more attributes. So that means person has NIC, name, address, birth date. So employee, addition to these, it needs employee ID, salary, and hire date. So how to create this class? So assume that you have already created the person class. Okay, person class. So then you can say employee subtype of person and your additional attributes because person already have the other attributes like NIC, name. So student subtype of person and then the additional attribute because person has the common attributes. Okay. මං කියන වචනයක් හරි තේරෙන්නේ නැත්නම් අහන්න ඕනේ හැබැයි යා. පස්සේ කියන්න එපා නිකන් අනේ මන් දන්නේ නැහැ මේක මහ ඇණයක් කියලා හරි. IT කරනවා කියන්නේ එහෙමද engineering IT කියන්නේ challenge, facing challenges, handling complexities. Okay. So these are some more examples. So this is geometric object class or type and circle object is subtype of geometric object and additionally you have the radius. If it is a rectangular object or rectangular class, it's a subtype of geometric object and additionally you have the width and height. Just some examples, okay? And maybe you have some additional methods. So, or you can override. You can see calculate area should be abstract method. Because if it is a geometric object, how do you know how to calculate the area? But definite actual implementation will be available in circle because it's 5r squared. In rectangular object, it is width into height. So here it should be just a method signature, abstract method. So remember when it comes to inheritance, you can have both single inheritance and multiple inheritance. We discussed that in semester 1. Java support only single inheritance. C++ language supported multiple inheritance. Almost all the other languages discontinue using multiple inheritance. Right? Starting from Java. C# still support multiple inheritance because C# has a lot of connection to the C++. But all the other languages, but anyway, they very rarely use multiple inheritance even in C#. But other languages like Java, PHP, Python, actually you cannot use multiple inheritance. It is not available because it's an unnecessary complication. Okay. So we discussed that if you allow multiple inheritance, it lead to the phenomena called double diamond death. Double diamond death. That is something we discussed in semester 1. When you have this kind of scenario. Now you don't know whether it's inherited from this side or this side. Okay, ambiguity. Actually, this I explain you that this phenomena is an issue in not only software development. Remember, inheritance is there in humans in a different way. So there are some. That is why they say don't uh, have marriages, or if you are planning to make children, don't. It's not recommended to have marriages between blood relations. And the ලේනාය අතර උනොත් මොකද වෙන්නේ? සමහර ලෙඩ රෝග හැදෙනවා, අංග විකල ළමයි හැදෙනවා. තියෙන chance එක වැඩි. සමහර ලෙඩ රෝග හැදෙන්න තියෙන chance එක වැඩි. මොකද මේ inheritance වෙනකොට මේ දෙපැත්තෙම inherit වෙන ගිලක් mix වෙනවා. Right? So that is biology. right? Biology side, but this is in programming side also. Multiple inheritance lead to additional complexities, ambiguities, right? So this is multiple inheritance. You can see this say inherit from multiple classes. This is fine, but this is bad. Class having multiple subtype is multiple inheritance. The class can have multiple subtype, but class cannot have multiple supertypes. If it is, then it's a multiple inheritance, which is not supported by a lot of modern languages, right? So the reason is ambiguity, right? Double diamond depth. Both these subtypes have the function with the similar name. දෙන්නගෙන් වෙනවා මේක. දැන් මේ කොයි එක්කෙනාකද ආ ඉම්ප්ලිමන්ට් කරේ? ඉංජිනේර් එකද මැනේජර් එකද? තවත් දරුණු වෙනවා මේ පැත්තෙන් ආවොත් එහෙම. මෙහෙන් දාවේ. Okay. So how to overcome that ambiguity or the negative effect of multiple inheritance? If you really want multiple inheritance, first solution is restrict multiple inheritance, like Java language, Python. In your object-oriented database also, you can say multiple inheritance is not allowed. Or else you allow, but with restrictions. So these are the possible restrictions. Because just because you use multiple inheritance, it doesn't get into problems. Problem is you use multiple inheritance and then use the scenarios that lead to double diamond depth. That is where the issue is. So therefore, another solution is you allow multiple inheritance, but you check whether double diamond depth is there. In that kind of a situation, you restrict that kind of usages, right? So check for the ambiguity during the creation of subtype and let the developer specify the function which should be inherited. Or use a system default. Or when there's a ambiguity, you completely stop it. Give an error message and say, no, this is invalid usage. So what are the three possibilities? Check for the double diamond depth kind of ambiguities and restrict. You are not restricting multiple inheritance. You restrict that kind of ambiguous inheritances in your code. Like you simply prevent overriding that method or calling that method. Or you use a system default. If you get something like that, you have a system default, say maybe the first class, you always get it from the first part. If a class X is a subtype of class Y and Z, so there can be a system default saying high priority is for the left class. So then no ambiguity. So if something is inherited from both Y and Z, it is actually inherited, you to consider it as inherited from Y. System default. Or you need to force the developer to specify in that kind of a situation, you must specify whether you override the method coming from X side or Y side. You can't just override, you must specify this is I'm overriding the inheritance method coming from X side, left side, right side. So these are three sort of possibilities. So these can be possible questions. So far they have not asked these, but examiner is always looking for new questions. So they can ask what are the three possibilities or list down three possible ways of handling multiple inheritance. So the ambiguity related to multiple inheritance. So complete restricted. That means not completely restricting multiple inheritance. Use of that kind of ambiguous usages, or use a system default in case of a ambiguity, or let the developer force the developer to specify whether it must inherit from which supertype. So then the problem is solved. Or else your object database management system can say, we don't support multiple inheritance. That is also fine because if your program is software is Java, Python, anyway, programming language also doesn't support. So then that is fine. But if your programming language support multiple inheritance, so then you need to go for this kind of a solution. Otherwise, again, the programming part and database is not compatible. Okay. So advantage of multiple inheritance is you can inherit from multiple classes. So just like you inherit from your father and mother, isn't that bad? Inheriting from more than one classes. Otherwise, you inherit only from one. So when it comes to biology, so there's something called some even trees, right? So you don't have inheritance from two, right? There's no pollination, right? Pollination නේ දෙකට කියන්නේ පරාගනේ. මයොක්ක දණ්ඩක් ඉඳුවම ආයෙ මයොක්ක ගහක් හැදෙනවා. දැන් කොහොමද ගහ වෙනස් වෙන්නේ? අම්මගේ හරි තාත්තගේ හරි දණ්ඩ නිහිත හිටවල තියෙන කලවම් එන්න විදියක් නැහැ. So that is a disadvantage, right? It doesn't mix things. So likewise, so you need to think. So in programming, multiple inheritance means you inherit from multiple classes. So then someone will say, why Java doesn't support it? Because of that issue, and rather they prefer use of interfaces. Use of interfaces rather than use of multiple inheritance because it does the work in a different way, much safer way. And sometimes people say multiple inheritance is bad. And sometimes people say even inheritance is bad. That is why there are some languages that doesn't support inheritance. Rather, they come up with different techniques, like always rely on composition rather than inheritance. So it's a lot of possible solutions are there. Okay, a lot of possible solutions are there. Yeah, C++ doesn't have the interfaces because it supports multiple inheritance. Okay, because C++ is the first serious object-oriented programming language. So therefore, C++, when software developers start using C++, only they encountered this issue. So therefore, C++ doesn't have the solution because they are the first, pretty much the first to come up with this concept. So then others fix it, make it safe, make it simpler. Okay. Right. Selective inheritance. So selective inheritance means you enable this is different, right? So this is solution for multiple inheritance with support multiple inheritance without ambiguity. Or else you don't support multiple inheritance. So this is support multiple inheritance without ambiguity by these restrictions. Now we are into a different concept called selective inheritance. So selective inheritance means you can restrict some methods and attributes to be inherited. So remember we discussed in Java final methods. Final methods you can't override. Right? You can't override. Private attributes you can't not inherited. Private attributes and behaviors not inherited. If it is a final method, you can't override. So likewise, we can restrict. Now, how do we do that in database? Right? So we can specify that only some functions and functions are inherited. So basically, in other words, you make it private. So then private things are not inherited. That is called selective inheritance. So these are more related to the programs rather than database, because database side, you don't care much about behaviors. This is selective inheritance is more related to behaviors. Okay. Right. So then the polymorphism. Polymorphism is also more related to the programs rather than database. Okay. Because remember, polymorphism is all about overriding, implementing different interfaces, playing different roles. So playing roles is calling behaviors. Calling behaviors is more related to programs rather than database. Okay. So therefore, we don't discuss much about polymorphism, but they have mentioned as a concept. This concept is also there. Okay. And they have given you some examples, but those are not much related to database, right? For example, overriding a method, of course, but this method is going to be executed in your programs rather than your database. Okay. So therefore, no code related to this. Just what is polymorphism and runtime late binding is, or dynamic polymorphism is. And of course, they have not given you anything about interfaces here, because it's again more related to the programming side rather than database side. Right. So remember, polymorphism is pretty much using dynamic late binding. Remember, in the web development also, I explained object-oriented analysis and design. I explained you the last time I explained briefly what is framework is, what is Hollywood principle is. Don't call me, I will call you. Right? Code your framework to interfaces, super types, so that subtypes can override, so that dynamically runtime the subtypes overridden methods are called. Serious stuff. If you can understand those concepts, you can be a software developer one day, and maybe a software architect. Because if you are a software designer, architect, you use these frameworks and so on. Serious level. It doesn't mean that you need to understand at that level to do your final year project. Final year project, you need bit of understanding.
Sir, what is Hollywood principle?
So I explained it last class, right?
Okay, sir.
Yeah. So you can refer to the recording, because it will take more time to again explain it. Okay. It's more related to programming rather than the database. Right. That's it about object-oriented databases. Right. Object-oriented databases. That is a long topic. So now the other topics are small topics. Okay. Right. So now we move on to our second type of databases, or the third one. If you take relational databases, we have already discussed in semester 2, XML databases. Right. So remember, what is XML? Extensible markup language. What are the usages of XML? ඒවා මතක තියෙනවනේ. XML කරේ semester 2 නේ, web development. Can someone tell me what are the usages of XML? නැත්නම් semester 2 3 එනකොට 2 මතක නැහැ. ගේම් බෝල් යනවා වගේ නේද? ඒ පාර අරකට යනකොට මේවා මතක නැහැ. මේ ගේම් බෝල් ටික පැනලා ගිහිල්ලා. semester 1 ගේම් බෝයි, semester 2 ගේම් බෝයි පැනලා ගිහිල්ලා semester 3 එනකොට. Why do we have technology called XML?
to to create a structure for a markup language.
Yes. So we can create our own markup languages using XML. Then what are the usages of creating markup language? Tell me the usages of markup languages. because XML can be used to create your markup languages.
To build websites.
Yeah, if you use something like HTML, HTML is a markup language. So you can define your content, layout, right? So there's a heading one, then there's a table. These are the table rows, table data. So you can mark up your UI. That is one usage. One usage of markup language is you can use markup language to mark up the UI, user interface. Right? What else? So that is one usage. That usage you have learned in semester 2, HTML. දැන් මේවා දැනගෙන කරන්න ඕන හරි නැත්නම් අන්තිමට අගම්මුලක් නැහැ. Right? So that is one usage of XML, but that is not the only usage. So remember markup language, markup. So markup කරන්න UI විතරද? markup කරන්න UI විතරද? So why can't we mark up and save it? Say you want to save student record. So you just write student name, Nimal, end of name, say email, nimal@gmail.com, say end of email, maybe say languages, maybe collection of languages, or maybe, okay, let's forget about the languages. Say contact. අපි email එක ඒකට ගමු. Right, say contact. So under contact, this is the end of contact. You have email, say nimal@gmail.com, end of email. So then there's another contact called phone. Say 070 blah blah blah. So you can see we put, because phone number is also contact, email is also contact. So then maybe address, then you can have number, street, city. So you save it. So if you put it into that structure and save your student details, so then you are using XML database. Or you can use it to data transfer. You create your student details like XML file and send it to another system, or from server to client. So XML can be used to mark up your UI, answer data, save data. හරියට තේරුම් ගත්ත වැඩේ ඉවරයි. right? එකපාර තේරුම් ගත්ත වැඩේ හොඳටම ඉවරයි. So what are the usages? Markup UI, markup persistence things, saving things, markup and save, or markup and transmit as a data transmission. Okay. Another usage is we can use XML for configurations. Configurations කරන තැන්වල ලස්සනට structure එක maintain කරලා configure කරන්න පුළුවන් මේ XML language එකට ගියා. So there are XML configuration files. For example, in semester 4 you have enterprise application development. So there you will learn how to configure web XML files in JSP servlet development. File, say sample. Right. It's a traditional Java enterprise web application configuration. Okay. So you can see it's XML file. With it welcome file list එක. There's a mapping ආඩ කරන්න පුළුවන්. On XML වල usage. So this is not This is a configuration. This is also something like saving, but we don't save data like data record. Rather, we save our configuration. So this is at ඕන මේක persistence කියලා කියන්න පුළුවන්. But we want to save it in a very strict format so that we can identify these information one by one meaningfully. So the bit of meaning is also saved. Okay. So then JPA you can use XML rather than annotation. Table එක මෙයයි මෙයා මේ class එකට මේ table එක මේ field එක තමයි මේ column එක කියලා map කරන්න පුළුවන්. You can see this class is for this table and this is our primary key and this is our fields. Column එක මේ program එකේ field එක එනවා මේ database එකේ table එකේ field එක එනවා. Any other validations? Everywhere we use XML. Right, you can see that we can save your data using XML because XML preserve the structure, hierarchy, meaning, because your tags have meanings. You can define meaning. So therefore, it's another way of saving data. So if you use XML structure to save your data, that means your student records are saved as, or student objects or student records are saved as, actually student records then, it's not object oriented, as set of XMLs, documents. So you read your XML document and extract the records. So then we have XML database. XML database. Okay. Now there's an alternative for XML database, that is JSON database. And we already use JSON database, right? Can someone tell me a database that use JSON? Because we have already used it. Anyone? Which database that we have discussed? MongoDB, yes. In MongoDB, we save JSON objects. Of course, if you want, you can configure MongoDB to use XML as well. So what is the advantage of JSON over XML? මේව තමයි ඔයගොල්ලෝ හිතන්න ඕනේ. ඇයි මේ XML වලට වඩා JSON වැඩි වුනේ? Anyone? එහෙම හිතන කට්ටිය තමයි ඉස්සරහට ගිහිල්ලා software develop කරන්නේ. Designers ලා වෙන්නේ architect ලා වෙන්නේ. මොකද architect ලා designers they do decisions make they do the decision making. So not every architect is a good architect, right? So their industry is looking for the best architect. So best architect means, say there are 3 software designers, architect, maybe your decisions are better. That means you have very
JSON use WP concepts. Okay.
Double OP concepts. Yeah, in a way, that answer is also valid. And actually, it's a very good answer also because the name itself also says, right, JavaScript object notation. වචනේ දිහා බැලුවත් ඔයාලට guess කරන්න තියෙනවා. JavaScript object notation. මේ object කතාවක් තියෙනවා මේක ඇතුලේ. But other than that, there's another reason why JSON is preferred rather than XML.
Is it because of JavaScript
Yeah, that is another thing.
on client side and
Because JavaScript built-in support that is another example. Yes, but yes, all those are correct also. But when it comes to saving, one of the main reason why people prefer JSON over XML is JSON is compact notation. So when it is compact, it takes less storage. Remember we talk about databases. Databases having millions of records. So XML, every record has these tags, whereas JSON, right, at least JSON has only one tag, whereas XML has 2 tags, start tag, end tag. Right, start tag, end tag. So look at, write XML and ask, so you can generate the, right, say student. Okay, so it's submitted. Say sample. එයාටම කියලා වැඩේ කරගමු. මොකටද අපි මහන්සි වෙන්නේ? ඒකෙන් අලුත් තමයි නේද? අපි මහන්සි වෙන්නේ නැහැ. අපි ගාව තියෙන බුද්ධිය වැඩේ කරගන්නේ වහලට දීලා. Sample XML document. Simple. So this is a simple XML document. Now let's see what is corresponding JSON document. JSON object. And a කොට already compact නැද්ද කියලා. Right, so this is the XML and this is the JSON. So you can see JSON is compact. මෙතන name කියලා දෙපාරක් වදිනවනේ නේද? මේක දෙපාරක් වදින්නේ නැහැ. එකපාරයි. So that is the main reason why XML is less popular and JSON is more popular because it does the same task. At the same time, it is compact. Okay. ඒකයි මෙතන මේ දැන්ටම කියන්නේ මෙහෙම මේ දෙක තරකට දෙන්නෙක් ඉන්නවා කියලා. Okay. But at the same time, the XML has more advantages because we have done XML in semester 1, 2. What are the advantages? Now I told you the disadvantage. XML is not compact, but XML has a lot of advantages. What are those advantages from your semester 2 knowledge?
Using well-formness rules.
Yeah, XML has some well-formness rules, schema, namespaces, so that we can enforce, we can control our documents. Right? It's more versatile. It's bulky but more versatile. Okay. So that is why XML is also used in some database, object-oriented and non-object-oriented databases. Okay. So it's some databases prefer XML, some databases prefer JSON. Right. So these are the usage like layout, specification of layout, and we are more interested in saving persistence. Okay, persistence. And XML is good for not only structured, of course, for structured XML is super, right? Because XML preserves the structure. At the same time, XML is flexible enough for semi-structured data as well. It may not be the ideal for the unstructured, just like JSON is also not ideal for the unstructured, but it's fairly flexible for semi-structured as well. So that means both structured and semi-structured, you can save using XML. Semi-structured. Because you can even have graph-like data structures in XML. We have the flexibility. If you do not restrict using schema, you can dynamically add your own tags. Right? But if you want high structuring, yes, have your schema defined validations. But if you don't have those things, so then it's more semi-structured. Okay. So it can be very strict structure as well as semi-structured, good for both. That is one of the disadvantages of relational databases, right? It's not good for semi-structured. So when it comes to semi-structured, it's not hierarchy. It's more, it can be even graph. It can be even graph. And of course, if it is unstructured also, maybe you can keep it. Okay, but not like multimedia and images, okay? But even for images, we can use bit of XML. Can you give me an image type which use XML to save that image? Image file type that use XML to save that image. Yes, SVG. SVG is XML base. Right. Say sample SVG file. I think XML. So rectangular shape, text. I think. දැන් ඔබ save කරගත්තොත් මොකද වෙන්නේ? Image එක. Say copy. මේකෙදි හිමීට හදිසියක් නෑ අපිට. තේරුම් ගන්න හදිසි වෙන්න ඕනේ නෑ. තේරුම් ගත්තට පස්සේ කිසි හදිසියක් නෑ. තේරුම් ගත්තට පස්සේ මුකුත් කරන්න දෙයක් ඉතුරු වෙන්නේ නෑ. වැඩේ ඉවරයි. තේරුම් ගත්තේ නැත්නම් තමයි හිස ගිනි අරගෙන නේද? හිස ගිනි අරගෙන දුවන්න වෙන්නේ. ගමරට වටේ. Say my image .svg කියලා save කරමු. SVG. Do we have SVG? අද පස්සේ rename කරමු. Right, where is my image? All right, my image is SVG. So let's open it in browser. බලමු මම මොකක්ද generate කරලා දුන්නේ කියලා. I think text එකක් තියෙනවා, circle එකක් තියෙනවා. Right? There is image. ChatGPT එකක් දාලා දෙන්නේ මම අන්තිමට. ChatGPT නේ browser එක දැම්මත් ඕලන්න. Okay. මේ ChatGPT generate කරපු එකද නෑ. So let's put it into a new tab. I think that is the ChatGPT's output, right? Right, you can see. Right, so therefore, those are the usages of XML, right? Vector graphic. Okay, right. So it's good for structured as well as semi-structured. Okay, and even for some bit of unstructured. Right, so now these things you know, right? XML has only, what are the type of contents allowed? Elements, attributes. What is the third one? Elements, attributes. දැන් මම අහන්නේ ඔයගොල්ලන්ගෙන් මේ semester 2 වල කරපු හන්ද. What are the three type of contents supported by HTML? Elements or tags, attributes. What is the third one? What are the third type of content? XML support. Only these three are supported. Elements or tags represent a concept. Attribute provide additional information about that concept because we have done that, right? ඒවත් ආයි කරන්න ඕනේ නැහැ semester 3 වල. මොකක්ද තුන්වෙනි එක? No one? Elements, attributes, entities. Entities are placeholders for something else like ampersand NBSP, ampersand copy. Okay. So therefore, you can even provide additional details about data in XML using attributes, which is good, like metadata. This is a sample XML. Right? Your element can be simple element or complex element. Simple element means something like name, Nimal. Complex element means address. So then inside that you have number, street, city. So then it's a complex element because inside that you have another set of tags. But if inside that if you have just the data or text, it's a simple element. But complex element create hierarchy of elements. Then you can define your structure using schema document or DTD. Schemaless means your XML is liberal. You don't have a predefined schema. So schemaless XML is preferred for semi-structured data and maybe unstructured data. But for structured data, go for schema. Okay, restrict the structure and you can validate. Okay. Right. So when it comes to XML, මේ slides වල තියෙන ඕන දෙයක් XML එකට අහන්න පුළුවන්. හරි. තියෙන දේවල් නෙවෙයි නැති දේවලුත් අහන්න පුළුවන්. නැති තියෙන දේවල් කොහොමද අහන්න පුළුවන්. අහන්න තියෙන chance එක වැඩි. Right. So this is a different classification of XML. XML documents. Another classification. So that is data-centric XML documents. Like you save your data, like our SVG file, or you save student record, or you just transmit from server to client your data as XML document. So then it's data-centric. Mostly those are schema, right? If it is structured data. Okay. That means mostly it is data. Then document-centric XML. This is data-centric. So it's more document. So that means lesser number of tags, more text. Lesser number of tags, more text. Like you try to configure your Word document in XML. So that is document-centric XML. Okay. Then hybrid means you have both text and data. Mixture of both text and data. Right? It's not a big thing, but anyway, examiner can ask this, right? Because it's in your slides also. Right? Not only one slide, right? It was a slide, second slide that explained, right? Data-centric XML because we are into the database subject, right? So data-centric XML document you can save in your XML database. So this is more data-centric. ඔයාලට පේනවනේ පුළුවන් තරම් මේක ඇතුලේ තියෙන data. මේ හැලී නැහැ. හැලී නැහැ. If it is a Facebook post and its comments, so then it is more document-centric. So here, well-defined structure, maybe we can go for a schema. Okay. So document-centric means large amount of text, right? And bit of tags. Few or no structural elements. It's more data, bit of structure. Okay. Something like this, like HTML document. Hybrid means you have both data and documents, text. Okay. Actually, HTML is more hybrid. Right? You have data like formatting and blah, blah, blah. At the same time, the contents, like web page contents. Especially if it's a news site or something, it's hybrid. Right. Any questions? That's it. The SQL අපිට ලොකුවට කතා කරන්න නැහැ. මොකද අපි XML කතා කරලා ඉවරයි. Schema, DTD, well formness, validity in semester 2. So database management system can use XML to save your records. So each record can be XML document. But again, this is less popular because of the high popularity of JSON. Okay. Right. Any questions? Any questions? Right. Now we can move on to NoSQL databases. So NoSQL databases are getting more and more popular these days, especially when we use mean stack. So MongoDB is heavily used, which is NoSQL database. So the reason why we are getting more and more NoSQL databases, because now software developers, software engineers feel like relational databases are very restrictive. Right? It's very restrictive. It's good, but it's sometimes too much of restrictions because it's structured database. So we need more and more semi-structured data. So when it comes semi-structured data, uh, JSON objects format is better, more flexible, more efficient. Right? So in that kind of situations, we go for more and more NoSQL databases like MongoDB. Still, if it is application like banking application, where you save your transactions, right? Uh, Account details, if it is student management system, payroll system, order processing system, yes, still we go for relational databases, which is superb, right? Superb. There's no alternative. Or maybe object databases if you want the full features of object orientation. But there are plenty of usages of NoSQL where your data is more semi-structured. Can you give me 3 examples of possible use of NoSQL? That means 3 examples where you use semi-structured data rather than fully structured data. I need 3 examples, one each. Where your data is more semi-structured. It's not highly structured, but bit of structure is still there. But you need bit of flexibility and bit of text heavy also. When we do the past papers, you will find that this is one of the type of question. Scenario එකක් දීලා අහන මොන database එකද හොඳම කියලා. හැම අවුරුද්දෙම question එකක් තියෙනවා. Right, email. Yes. It's bit of semi-structured. Relational database is not good, right? To save emails? No, that is not good. So actually, emails are not saved in your emails management systems in relational databases. So NoSQL database is preferred because email can have reply to reply, right? Then reply is coming from if you have CC to multiple people's, different people's reply. So now you need to save that. So relational database, you can save it, but it's very inefficient. So many query joins, so many inefficiencies when you retrieve the data. But if you have saved it in a JSON object or even XML, you can straight away load the entire email thread. The original email, its replies, reply to replies, everything you can load it to the memory. ඒක කරලා කරන කෙනෙක්ට තමයි තේරෙන්නේ කොච්චර ලේසිද කියලා. අර ගිහිල්ලා SQL ලියලා ඉන්න අපි දන්නේ reply කීයක් ගහලා තියෙයිද? ඒ පාර හොයන්න ඕන reply තව තියෙනවද කියලා. So keep going to the file because these are in tables. අර රෙකෝඩ් එක ගත්තම තමයි දන්නේ මේකට තව reply එකක් තියෙනවා කියලා. මේ ඒ රෙකෝඩ් එකේ තමයි තියෙන්නේ ඒකට තව reply එකක් තියෙනවා. දැන් ගිහිල්ලා ආයි database එක access කරනවා. ආයි file handle කරනවා. සමහරට reply 100ක් reply 15ක් තියෙනවා 15 වතාවක් ගිහිල්ලා disk එක access කරනවා. But if it is saved as a JSON object, one shot you retrieve entire thread, email thread, super fast. Right. Any other usages? Yes, social media. Facebook නේද post දැම්මම post එකට comment දානවා, comment එකට comment දානවා, comment එකට like දානවා අයස්සේ. post එකකට දානවා අමතරව. හරි. It's a hierarchy of things, semi structure. අයස්සේ හැලිත් තියෙනවා. Text and document. Okay. reply කරලා සමාන. So likewise, for those kind of situations, relational databases are not well good. Actually, those are very poor. You can save it, but it's very poor solution. So NoSQL databases, XML databases are going to much more suitable. Okay. Some catalog details. Okay. And so on. Right. So what is the main reason for NoSQL databases? Because programming languages, in programming, we have a bit of flexibility, but database, a lot of restriction because relational database is very restrictive, right? We have well-defined tables and you expect record structures accordingly. So that is called impedance mismatch. That impedance mismatch is one of the reasons to having object-oriented database also, right? Programming object-oriented database relation. That is also impedance mismatch. Programming, you have a lot of flexibility. Database, you have a lot of restriction. That is another impedance mismatch. So one solution is object-oriented database. For that impedance mismatch. For this impedance mismatch, where programs can handle your content flexibility, but your database is very restrictive. That is another impedance mismatch. The solution is NoSQL XML databases. So memory is very flexible. Right? Memory is much more flexible. In memory, we can keep data. That is why you have the data structures and algorithm, right? In the memory, you can keep your data in binary trees, linked list, arrays, binary trees, graphs. On a data තියාගෙන ඉන්න විදිහ. එවන subject එකට connect වෙනවා. So in program, you manipulate your data using graph, binary tree, but in your relational database, there's nothing called binary tree. But in your NoSQL database, you can save it as a graph. You can save it as a binary tree. අන්න mismatch, impedance mismatch එක කැඩුවා. So you need that same flexibility in our database. So that is why we have NoSQL databases. Again, NoSQL database is not a solution for everything, right? Sometimes relational database is the best, but there are situations relational databases are not that flexible. Okay. Object oriented impedance mismatch එක කඩපු එක තමයි. Because program object oriented, database relational. So that is one solution is object oriented database. Another solution is program flexible, database restrictive. NoSQL database is another solution for the second type of impedance mismatch. So remember, program is object oriented, database is relational. One solution is go for object oriented databases. Another solution is go for object relational mapping like Hibernate. So that is, you still use relational databases and you write object-oriented programming, but you map class in the program to the table in the database. So that is another solution. So now we have two solutions, right? For object-oriented object impedance mismatch, object relational mismatch. Either go for object-oriented databases or object databases, or use object relational mapping. Right? But object database is more flexible than object relational mapping. And for the other flex impedance mismatch, that is program memory structures, memory you have a lot of flexibility like trees, graphs, but your database is relational. The solution is go for NoSQL databases. Use JSON, XML based structures to save. Okay.
So what is impedance?
Impedance mismatch means the difference, mismatch. So there's a mismatch in the concepts. Mismatch in the concepts. So one is flexible, other one is rigid. One is relational, other one is object oriented. Okay. So all of a sudden, NoSQL databases have so many advantages in that kind of scenarios, and therefore it became very popular. And remember, we are living in a very dynamic, competitive environment. In dynamic, competitive world, you need more and more flexibility. People are looking for more and more flexibility, not rigidity. So therefore, in the future, we will need more and more unstructured, semi-structured data handling. So that is why NoSQL databases are going to be more and more used. Right? Again, it doesn't mean that relational databases will be completely wiped out. No, there are situations we need very strict data structures like banking systems, inventory management systems, order processing systems. Okay. Right. So still there's a possibility of using SQL and relational databases. At the same time, there's a possibility of some other applications where we prefer semi-structured databases like XML based, JSON based, okay, where you need more flexibility. And other than those, of course, so what now we are into the NoSQL databases, right? So flexibility, support for semi-structured data.
Sir,
Yes,
I have a question.
yes.
Uh, why do we need the JSON in database?
Because we want to save the data. So JSON, no, whatever,
Say,
there must be a way to save data. Structure,
okay,
preserving the structure. So if you have a
okay.
better way, they will use it. Of course, anyone can propose another structure, right? Just like JSON is an alternative for XML. Another person can propose another structure. So right now, the most widely used approach is JSON because you need to preserve the structure. Your data
So
itself. Sorry?
it's like a common structure.
Yeah. So that is common structure, just like XML is also like that, right?
Okay, sir.
So in the future, maybe something else might come to the surface. But right now, this is the most popular. Right. Other than those flexibility advantage of NoSQL databases, because it's more flexible, there are some other advantages also. That is scalability and availability. So we can easily distribute NoSQL databases. Distribute. We can go for distributed databases. Right? Because in relational databases, your data is related to each right? This table is related to other table and so on. So this is your employee details. This is your, say, this is your customer details. This is your order details. This is your item detail. This is your payment details. All are interrelated. But interrelated data is in different tables. So then it's difficult to scale it, keeping those different tables in different databases or different machines. So that means you need to access that machine, this machine, and other machine. Because you need maybe order details, payment details, maybe then order details in one machine, payment details in another machine. But if you go for NoSQL databases, we can save customer details, customers order details, orders payment details, everything in one JSON object or one XML document, so that we can load the entire thing from one machine. So then if you are having a lot of users, so then maybe different users data you can save it in different machines. Say branches, say supermarket, say Kohuwala supermarket details saved in one machine. Meerigama supermarket branch, its order details are saved in another machine. Say maybe closer to in their uh, site. But maybe we can access all these machines and get a report by the head office. Because all the data we saved it in a one document. It is more scalable. At the same time, when there's a need, you can relate those. So that is how it is done in Facebook also. So you get your post, say you are looking at your timeline. But when you click on, say, someone's profile name, say someone has comment your post. So if you click on that person, then you are going to that person's profile. That person's profile details may be coming from a different server. Maybe he is residing in USA. So therefore, his records are in USA server. But most of your friends are in Sri Lanka. So therefore, there's a high chance all those profile details are in Sri Lanka data center, the SLD data center. But maybe one of your friend is from USA. So then maybe in that kind of a situation, that profile, when you visit, you are getting that data from, but all the data is in that machine, not set of data in one machine, another set of data in another machine. Because we save it as a document, collection of documents. Okay. So there's a better scalability when it comes to NoSQL databases. And also availability. We can have these data set up in multiple places. And again, the entire data is set up in that machine. Not you are getting from that machine, this machine, and other machines. Because we save as a hierarchy of documents and so on. So that means high reliability, high availability, higher performance. Right. So when it comes to NoSQL databases, we have another flexibility. That is, we can decide how the data is stored. Right? We can decide, okay, data must be stored in XML format. Data must be stored in JSON format. Data must be stored in key value format. Data must be saved in column family format. So likewise, we can decide or we can configure how the data is stored internally. Okay. Or we can say data must be saved as a graph. Okay. That is another advantage. And sometimes we can save our data in multiple formats. Some data in JSON format, some data in key value format, some data as a graph. Okay. For example, if you take Google, if you go to Google Map and so on, Google search, Google Map, sometimes you start with Google search and ended up with Google Map, and then you look at some ratings of a vendor. So then your data is, some data better to keep it in XML, some data better to keep it as a graph, some data better to keep it as key value pair. Sometimes your same database can keep data in different formats, right? Picking the right data storage for the right use case. Possible to select the data storage based upon the nature of data, the way you manipulate and so on. So some data is in JSON, some other data is in XML. Some other data is in key value, some other data related to the same system. So then we call it polyglot persistence. That is additional flexibility. So use many data storage technologies to suit your data requirements. Even the same application. Okay. You can see same application. So some data is kept in key value pairs, some databases, some data use keep it in graph, and sometimes some data you can keep it in relational database. That means then you need to go for a different database also. Okay. So same database, different format is also there. Or else your application refer to different databases also. Okay. And some of the NoSQL databases are open source. Some of the databases are proprietary. Some of the databases you can install and use it. Some of the databases you only have the cloud databases. Okay.
Sir,
Yes.
are we talking like the blueprint of a database?
What do you mean by
Blueprint of a
blueprint of a database?
the blueprint of a creating a database?
No, we are talking about different possible solutions you have.
Okay, sir.
Okay. Other than relational databases for your system development. Right. So remember, we did not discuss how to work with object-oriented databases practically. Of course, semester 2, we discuss how to work with relational databases practically. And semester 2, we discuss how to work with NoSQL databases practically. Right? Of course, relational databases we discussed throughout your database subject, right? For the entire semester. So therefore, I hope you still remember the relational databases, right? But we discuss about NoSQL databases only maybe we just took 1 or 2 days, right? Mean stack. So therefore, I just want to refresh how to work with MongoDB before moving to the aggregate data models, okay? So if you want to work with MongoDB, of course you must, right? Because it's in your syllabus. It was in your semester 2 syllabus also. So there are two options. Either you can use MongoDB as cloud community cloud server, or you can install and use it. It's up to you, right? It's up to you which approach you like. Of course, if you install it, you have better flexibility, but otherwise, of course, cloud environment also you have a bit of flexibility because you can access it from anywhere, but you need internet and so on, right? It's up to you to use whatever the approach I told you in semester 2 also. So in my case, I have installed MongoDB, download and install. Okay. So let me close this. So when you install it, you can search for MongoDB. Compass, that is the easiest way to access your MongoDB. I have a bit of older version, I think about 1 year old version. If you have the latest, that is fine, okay? Right. It has updated Compass 1.46.7. Right. So then it's very easy. You don't need to start database anything, right? Because using Compass, you can do everything. Here you can see add new connection. So it will start your database and no, I think it's already started as a service. Let me double check. I think we just connect to it. I think MongoDB start as a service. I don't know. It depends on the way you install it. Let me double check whether there's a service called MongoDB. MySQL. Yeah, MongoDB is running. So I have installed it as a service. Okay. I have installed. I think that is by default installed it as service. I can't remember because I installed this about 1 year ago. Okay. But anyway, my MongoDB is up and running. So just double check if you get error or something. So now you guys must be able to analyze your errors. Search in the Google, ask from ChatGPT. Right. Use the WhatsApp group if you have any errors. Right. So anyway, my MongoDB is up and running. So you can say new connection, localhost. MongoDB by default start 27017 port. Okay. And that's it. You can just say connect. Okay. We did this in semester 2. You say connected. Okay. And this is your connection. My partner connection pen. Yeah. I already have some databases. අපි semester 2 කරපුවාම I think semester 2 කරපු database. Right. So we had some collections, book collection, student collection, test collection. Test එකේ නම් record නැහැ. Book එක තමයි පාවිච්චි කරේ. ඒකේ තියෙන එක record නැහැ. Right. So remember in MongoDB we have your database has collections rather than tables. The concept is collection. Right. So there's nothing called tables because you save documents. You save documents in a collection, and that collection can be, or your document can, your collection can have even different type of documents. Right? Collection is not restricting you to keep only one that kind of that structured document. No, your collection also can have. That is why we say unstructured. So the semi-structured, slightly different structures. Okay, and your document can be also semi-structured. So hierarchical. Okay. As long as it's a document, your collection will accept. Of course, don't add order into the payment collection and payment into the customer collection. That is, you use it like a monkey. So flexibility is there, but you need to use it in a responsible manner. But you are given the flexibility. At the same time, you are given the responsibility. Okay. Right. So how to create a collection? Semester 2 වලදී මම ඔය note එකක් දුන්නා නේද? Note එක නැත්තම් right mean note එකේ තියෙනවා හරි. Mean note එකේ work with data. So this is the semester 2 mean note. So there we discuss about all these things, right? මේ ඇවල පරණ විදියට කනෙක්ට් වෙන විදිය තියෙන්නේ. ඔයාලට අලුත් විදියට කනෙක්ට් වුණාම ලේසි හරි UI එකේ. Right. First of all, you must know the JSON structure that you learn in semester 2. Right? Name value pair, name value, name value, name value. And the value can be again a JSON object or collection of JSON objects. Right. You can have the null values. Okay. So this is collection or array of values, array of strings. So this is array of JSON object. So this say JSON object is array of JSON objects. Array of JSON objects. So මේ ඇතුළට ආයෙම JSON object එකක් එන්න පුළුවන්. නැත්නම් ආයෙ array එකක් එන්න පුළුවන්. Array of values, array of JSON objects. So it's recursive. Okay. So you can see this is JSON object. It has a menu, which is another JSON object. And that JSON object has ID, which is a string, value, which is a string, and pop-up, which is another JSON object. JSON object එක ඇතුලේ JSON object, ඒක ඇතුලේ තව JSON object. ඒ JSON object එක ඇතුලේ තියෙනවා list of array of JSON objects. Okay. So that is how you save semi-structured data. ඒ කතන්දරයට අදාළ සියලු දේ එකපාර save කරගන්න. වෙන වෙන table එකක් ගහන්න නැතුව ගිහින්. table එක වුණාට පස්සේ අර table එක වෙනම load කරන්න ඕනේ. මේ table එකේ වෙනම SQL එකක් ලියන්න ඕනේ. query කරන්න ගියාම SQL ලියලාම පණ යනවා. ඔක practical software develop කරන අය තමයි තේරෙන්නේ. SQL ලියන්න ගිහිල්ලා නේද? අරහෙන් ගන්නවා ටිකක් මේකේ ඒක අරගෙන ආයෙ තව SQL එකක් ලියනවා. develop කරන්නත් කාලය වැඩි. run වෙන්නත් කාලය වැඩි. ඔක්කොම data ටික එකට තියාගත්තම අදාළ ටික ඔක්කොම එනවා. And also we have the data types because it's JavaScript object notation. Right, how to create a database? You just say use and database name. මට කර පොඩි refresh එකක්. ඔයාලට පුළුවන් මෙතනින් command line එකක් ගන්න. MongoDB shell. Right. So now I have the MongoDB shell. So use and give your database name. Okay, I'll call it SEM3. Right. So still you can't see the database because once you create your collection only you can see the database. මම හිතන්නේ තරම් මට database එක පේන්නේ නැහැ. දැන් නැත්තම් collection එක පේන්නේ නැද්ද බලන්න. SEM3 කියලා database එකක් හදනවද බලන්න. No, I don't think no, right? Yeah. When you create your first document only you can see the database. Refresh කරන්න තැනක් තියෙනවා. Just refresh. SEM3 කියලා පේනවද? නෑනේ. Right. Still you can't see the database because you have not added any records to any of the collections. Okay. Right. So now let's create a collection. What collection hai kara? Now we have created the database, but still you can't see it because no document saved. Okay. So then you can switch that database. Use SEM3. දැන් switch වෙලා තියෙන්නේ. SEM3 එක දැන් හැදිලා switch වෙලා තියෙන්නේ. So then you need to create a collection or any number of collections. Okay. So db.create collection, your collection name. Okay, it's very simple. db.create collection. Right. So
you have put comma.
yes. Thank you. And you give a name. Okay, so let's say customer. Right. So OK means successfully created. Okay. So now I have the collection but no records. So therefore still you can't see the collection or database. Now you can create documents and edit, right, to that collection. Right. So your document must be a JSON object. Right. Something like this. Say your collection name, insert one. Okay. එතකොට මේක වෙනස් කරගමු employee කෙනෙක් වගේ. Say this is employee. We called it employee, right? Yeah, customer, sorry. Customer. Okay, collection name is customer. එහෙම collection එක නැතය හදනවා collection එකක්. හරි. හදලා insert කරනවා. Say name Nimal Pereira. Salary $120,000. Say department. Say HR. Say finance. So last one you don't need comma, right? Right. So this is the object ID. Machine generated object ID. Right. දැන් බලන්න තියෙනවද කියලා set refresh කරලා. Now you have the same three because you added the document. Yes, customers. And this is our object. Okay. So if you want to insert multiple records, you can use insert many. Right. Insert many. Something like this. මේක කළා කරන්න ඕනේ. ඉතින් කරන්න නැතුව මේක තේරෙන්නේ නැහැ නේද? Right. Customer. Say name, salary, department. Let me copy paste. Having comma for the last one is okay, I think, right? Let's not have it. Right. So let's say Rehana Fatima, whatever. Kevin Shaw. Then this guy is in finance, HR, again finance, say MKT marketing. Right. So let's see whether we can insert this. Then right. Object IDs are there. Okay. Right. So now how do you get all the records? DB dot customer, because we are already connected to the database, dot find. So all the records. Then go the restrict kala search kara. Say I want the employees from department finance, say finance department. So you need to say what is your ID, what is your name, okay, and so on. What is your, we can say use salary, customer, find, say department, let's say I'm only interested in finance department employee, FIL. So now I'm supposed to get only 2 records, right? How many finance? Yeah, 1, 2, yeah, just 2. I think we need quotes or something. Yes, so we have the finance department employees only. So then see how to do update, how to do a delete. So you have the note, right? Right. How to do the update, update 1, update, right? And save is used to again you can use save to update as well. Okay. And delete, you can use remove, or you can filter and remove selected records only. Okay. Right. So any questions? Because those are the things you're supposed to do, right? Insert, update, delete, query. Now you don't have, remember when you learn SQL, you had a headache, right? Inner join, left outer join, right? Having, now here things are easier because we save the related data as a collection. Still you need to do some querying, but things are easier. Things are getting easier. Not only easy, performance-wise also, the related data is as in a single collection. Very rarely you need to connect collections. You need to, but not all the time. Okay. Right. Any questions? Right. Now we move on to the aggregate data model because today we want to finish it, right? So we will not be able to fully finish it in this session. So we will finish it in the evening session. Okay. එතකොට අපිට මේක past papers කළ ඉවර කරන්න පුළුවන් මොකද මේක ලොකු topic එකක්. හරි? මම කිව්වේ this is the hardest subject. Right? Hardest subject. මේක මෙහෙම නෙමෙයි net transaction එහෙම කරන්න ගියා. හරි? Much harder than this. Right. So therefore, let's do it for another about 15 to 30 minutes and stop it. And then we'll finish it in the evening session and then we'll move on to the web development or data structures. Okay. Right. So now we move into our next type of databases, database management system. That is aggregate oriented. Okay. Aggregate oriented databases. Where did we stop? Yeah, aggregate data model. So aggregate oriented data model, we save it as related objects. Actually, so now also we have save it something like that, but remember we only saved customer. So if you save customer with its orders with its payment, so then it's aggregate. Okay, then it's aggregate. So an aggregate is set of related objects that is treated as one unit. So that means your collection has not only one concept, its related concepts also you save. Okay. So then you call it aggregate oriented data model. So you can see same NoSQL, right? It's not just document now. Document means one concept. Aggregate means multiple concepts, related concepts, you save it as one aggregate. Okay. And when you use aggregate approach, the application programming is easy because you load not only the data, the related data also. Right? So you have the data, all of a sudden you have all the related data for your UI and so on. Because you have saved it as a one aggregate. So you put together all the related data so that you can access together, save together, update together, retrieve together, insert together. Okay. So this is good when we have complex relationship structures like customers order items, payments, maybe part payments. So that payment for that particular order. So payments are aggregated inside the order. Right? So in your final year project, if you want, you can use MongoDB. Actually, last year also some students use MongoDB and mean stack for their project. Right? But you need a bit of more confidence to do that, right? A lot of students prefer to go for MySQL, PHP because ගොඩක් අය ඒගොල්ලන්ට MyS මේවට යන්න බැරි ඒගොල්ලෝ ක්ලාස් එකේ මේව කරලා නැහැ. ක්ලාස් එකේ මේව කරලා නැහැ. ඒතකොට ඉතින් අන්තිමට මොකවටත් කරන්න සමහර මොකවත් කරන්න බෑ. Javaත් බෑ, PHPත් බෑ, Meanuත් බෑ, MySQLුත් බෑ, NoSQLුත් බෑ, මෙලෝ මගුලක් බෑ සමහරුන්ට. ෆයිනල් ඉයර් ප්‍රොජෙක්ට් එක කරන්න කොහොමද ඒතකොට? Right. So therefore, aggregate oriented means you save your data and related data or associated data. So rather than associated data, we call it as aggregation of data. You can see customer and customer's orders because customer is associated with order. Order is associated with order item. So then order is associated with payment. So customer and payment are associated with the billing address. So billing address structure. Okay. Maybe order also has a billing address. See, it's like a now network. You don't need to save this multiple times because this same address. If it is different billing address, yes. So it's a different billing address. Now this address is shared by your customer, order, payment. You have everything as an aggregation. And from order, you can reach order payment, billing address using dot notation. It's very easy to access. Not like SQL writing joins. මේ foreign key එක connect කරලා join ගහන්න ඕන ආයේ ඒකෙන් මේකට join ගහන්න ඕන. ඊට පස්සේ එන data එක එන්නේ එක row එකක් වගේ. දැන් මේ join ටික ගවුවට පස්සේ data ටික එන්නේ කොහමද? මේම පතරංගයක් වගේ එනවා data set එකක්. ඕකේ orders උත් තියෙනවා. මේ multiple ආවට පස්සේ මේක repeat වෙවි යනවා. කරලා බලන්න ඕන කන පරිප්පුව. relational database එක. මේවට query ලියන්න ගියා. කරලා බලන්න ඕනේ ඒක. එතකොට තේරෙයි මේ කොච්චර ලේසිද කියලා. හැබැයි මේක ලේසි වෙන්නේ මේක ඉගෙනගෙන ඉන්න ඕනේ ඊට කලින්. So in this example, the main aggregates are order, custom. මේ දෙන්න වටේ තමයි මේ දෙක අනිත් ඒවා කරගන්නේ. හරි. But at the same time, they are also related. They are also related. ඒ දෙන්න association එකක් තියෙනවා. මෙන්න මෙයාගේ aggregations ටික මෙයාගේ aggregations ටික. Aggregations කියන්නේ මෙන්න මෙහෙම දානවා. හරි. Right. So next one is key value model. මේ ඔක්කොම එකට කලවම් වෙන්න පුළුවන්. හරි. It's key value, aggregate, document. Okay. තාම අපි NoSQL NoSQL එක ඇතුලේ ඔක්කොම එකට තියෙන්න පුළුවන්. ඔයාගේ JSON object එක. So key value means, as the name says, key and value. You save it as a key and value. For this key, this is your value. Value is a JSON object. Then that JSON object may be aggregation of other objects. Maybe those objects may be having documents. Okay. Key value. Actually, here also it's pretty much a key value, right? I'm going to close it. OTP. So here also this is our key actually. But key එක ඇතුලේ values මේ key එක ඇතුලේ තියෙන value එකක් නම් එතකොට තව JSON object එකක් නම් key value. So here it's not a, if you take this as a key, this is not a value, this is set of values. Maybe key has another JSON object. So then it's a key value. Okay, key value. Okay, so let's ask ChatGPT to generate a key value JSON object. Let's say JSON object for shopping cart. Okay. This is a very famous example for key value database. You can say use ID, that is the key. Okay. Sorry, cart ID and the use ID. So then items. So then this is the key. Here the key is cart ID. This is just a property. So this is your second property of that related to that key. So this cart ID belong to this user and these are the items. So then each item you have another key and these are the values. Another key. These are the values. So this is item 2. Okay. This is a key. These are the values. Right. So then these are the rest of the values for this particular key, cart ID. මේ cart ID එකට මේ key එකට අදාළ user එක හැදුවා items එක ගත්තා. දැන් ඉන්නව කවුද? යට ඉන්නවා currency. So this cart is on US dollar. This is the subtotal. This is the tax. This is the total. Right. It's a key value. So මේ key value එක ඇතුලේ aggregation උත් තියෙනවා. ඉතින් aggregation එක ඔක්කොම එකට යනවා. So we can store all of that information in one bucket as single key and single value object. Then that object can have again key value. You can get it to up any level. So then key value and aggregation. Okay. So you can see key value. So then this can be again key value. Okay. Like these are some examples: session handling, shopping carts. So this is another key value example. Right. So document data model we already discussed, right? Document are basic method. අපි ඉස්සෙල්ලම දැන් document එකක් නේද? හැබැයි document එක ඇතුලේ ආයි JSON තියෙන්න පුළුවන්, ආයි XML තියෙන්න පුළුවන්. Or your document has only some text or primitive values. Okay. ඒක අපි කොහොමද කරලා තියෙන්නේ? So we can use to store documents or any other document oriented thing like invoice, okay, application and so on. Right. So our final NoSQL data model is column families databases. Column family. So this is sometimes you get confused. So therefore I have added you another recording also in the Google Classroom for this one. Okay. So just go through this 10 minutes video also. But exam ළඟ වෙනකොට සමහරට ආයෙ මේව අමතක වෙන්නත් පුළුවන්. ඒතකොට මගේ හරි අපේ class recording එකක් තියෙනවා. ඊට අමතරව quick refresh එකක් ඕන නම් මම තව recording එකක් දාලා දෙනවා. හරි. Right. So what is mean by column family? I have not saved on column family එකට පොඩි table එකක් හැදුවා. ඒක save කරලා නැහැ මන්නේ. Right. I will add that table and share this. Okay. පොඩි note එකක් ගහුවා note එක save කරලා නැහැ අමතක වෙලා. Right, so that is fine. I will edit again, okay? Right, so column family means, so we have two concepts, okay? Column family and column store. Right, column family, column store. Okay. So let me regenerate that from ChatGPT. ChatGPT generate කරලා summary එක දැම්මා ආයිම save කරලා නැහැ. So then I can use that note to explain. Column family versus column store. Database comparison table. Okay. මේ දෙකම එකට තේරුම් ගන්න ඕනේ නැත්නම් තේරෙන්නේ නැහැ එකක්වත්. හරි. Right. So there are two type of databases, right? They are related but two different type of databases. Again, those are NoSQL databases, okay? Or for semi-structured data. So one is column family database. Other one is column store database. ඔය දෙකම ආගේ note එකේ කලවමට තමයි explain කරලා තියෙන්නේ. So in your UCSC note, they explain both. හැබැයි අර එන් ටිකයි මේ එන් ටිකයි කලවම් කරලා දාලා තියෙන්නේ. So therefore you need to separate this. Okay? Right. What is mean by column? First I will show you the usages, okay? Right. That's the usage. let's say include usages. My column generate कर save करें ना. Right. It's not a very good usage. Here you have the usages, okay? Right, I will explain from one by one rather than usages. So when it comes to column family databases, okay? Sorry, column store databases, we access through columns. Now, this is how we explain it, okay? Recording එකේ තියෙන ලස්සන diagrams ටික මට ඒ diagrams ටික දාන්න දෙයක් නැහැ. PDF එකට copy කරන්න බෑ, හරි? Let me explain it using my pen. Say we have data, right? Data. This is for big data, okay? Big data means huge amount of data processing, thousands and millions of records, okay? So traditional approach of data processing is we process data records by records, okay? For example, you want employee whose employee ID is 2345, or you need employees whose name is Nimal Pereira. So then you get the correct record. Or you need employees from department 5. So then again you need set of records. Right. So you can see you process, your objective is get one or more records. Maybe your database has hundreds and thousands and millions of records. Right? So those are record oriented. Traditionally, yes, we process data in record oriented manner. And once you isolate, maybe you are only interested in some fields. But once you isolate the record, okay? But there are situations you process based on columns, right? Process based on columns, not based on records, based on a column. So you want all the data for this column, okay? So that is where we use column store databases. Column store databases. So stores each column separately for fast analytical processing. Okay. So store column separately. මේ column එක වෙනම save කරනවා. මේ column එක වෙනම save කරනවා. So that is not the normal way of saving data. Okay. Column wise save කරලා තියෙන්නේ. Why? Because we want to access this column, all the records. Maybe just column and primary key. Another file, this column and maybe not primary key and another column. So then you call it column store database. So why do you need that kind of a arrangement? Maybe we are not interested in record-wise processing, we are interested in column-wise processing. Say we want to find the average salary of the employee, or the total, say this is all orders. Say we have, say it's a multinational company, or multinational company where they have all over the world, they have transactions happening. So then you want to find what is the total turnover for the day, for that particular time period, last 24 hours. So then you need only the total amount of the or the bill amount of each in order. So you just need to get these values. Maybe you have millions of records, but you are only interested in this one because you want to submit. You are not interested in any other details. So then if you have that kind of a requirement, right? Requirement, maybe you can store it as a column store database. If you have that kind of requirements more than this kind of requirements where you interested in rows. So then you call it you can go for a column store databases. Is it clear? Okay, that is very rare, but in that kind of situation, you can go for column store database. Okay. So then column family database is, so this is when you want to store data in column wise. This is more useful in data analysis. You analyze on particular field or analyze on 2 fields. Maybe you have 10, 12 fields. Then what is column family database? Column family database means you have the flexibility of columns. It is just like your JSON, right? So that means you are not strict with the same columns for each record. You have the flexibility of, for some records, you have these 2 columns, some other records, you have these 3 columns, right? But you process data record wise. You need that flexibility for the columns, but you process data record wise, conventional manner. So then you can go for column family database, right? So two usage scenarios, two type of databases, right? Okay. So you can see still you store data in row groups, not columns. Here you store each column separately. Still you use as rows, but you have the flexibility of different rows having different columns. Okay, that is why we say column families. Column families. Okay, so these are some examples for column family databases like Cassandra, HBase, and these are some examples for column store databases. Okay. So this is column-oriented storage, but fixed schema, but column-oriented storage. This is flexible scheme, right? Not conventional processing, record by record processing, row by row processing, but flexible schema. This is fixed schema, but we process column-wise. This is more needed in data analysis. Okay, is it clear? Okay. So this is more suitable for data analysis. This is more suitable for transaction processing and so on. But big data. Okay. Right. So anyway, I'll add that back because I forget to save that Turing table එකක් හදලා දාලා තිබුණා. ඒක ආයි save කරන්න අමතක වුණා. හරි. Right. So that is the difference between in simple column family database versus column store database. මොකද සමහර තැන්වල column store ගැන කියනවා. column family ගැන කියනවා. හරි. දෙක පටලව තමයි වගේ note එකේ කියන්නේ සැරින් සැරේ. හරි. පටලව නෙමෙයි. examiner එච්චර ඒක separate කරලා නැහැ. හරි. So you can see column family. So this is columns family store. නැත්නම් column family store කියන්නේ column store. Okay. Right. So the next one is graph data structure. Graph data structure. Graph data store anyway. In your data structures and algorithm also, your final data structure is graph. So graph means interconnected nodes. But these nodes can be freely connected. There's no restriction. If there's a relationship, you connect. Okay. If there's a connection, you connect. So that is called graph. That is the most flexible data structure. Like interconnection of cities, interconnection of people, like Facebook friends. Right. So if you have that kind of data that you want to save, if you can save it as a graph itself, because otherwise you need to take it from tables and so on and again restructure that graph, which is a lot of processing, a lot of time. So therefore, if you can save it like that, like social network, user preferences, and so on, so then you call it graph data store. It's again NoSQL. NoSQL, but you go for the graph structure. Okay. So nodes connected by edges or arcs. Okay. Nodes connected by edges. So that is what I show you, right? Member connection theory. So these are the nodes. These are the edges or arcs. So we can traverse from one node to the other. Once you get it, okay, once you retrieve the data to the memory using Java, Python, we can traverse. But traverse can be data structures and algorithm. Right? There are different type of traversing. Depth first traversing, breadth first traversing. Then there's some problem solving like shortest path. So all those things we can do using programs, programming languages, but you need to store the data and quickly recreate this graph in your memory. So therefore, the best thing is you store it as a graph rather than going for other documents and so on. Aggregates, relational databases, you store your data as a graph itself. So then you use graph data stores. Is it clear? මේක හරියට වැඩේ තේරෙන්නේ නැහැ. අතනින් data structures and algorithm වල graph කරද්දී. Right? So we can traverse, we can join very fast. Okay. So this is an example for a graph. Right. So this is yeah, maybe this is like LinkedIn. Right, LinkedIn. Hired කියලා everything LinkedIn no. LinkedIn connections. So we can save this data as it is. As it is. Otherwise, you need to keep all these links in a model can විදි තියෙනවා හරි. So there are ways to model this, but that is how we used to do it before these NoSQL databases were there. Right? මේවා save කරන විදි තියෙනවා. ඒ විදි ගැන කතා කරනවා. ඒ කියන්නේ relational database එක save කරනවා නම් save කරන විදි තියෙනවා, but it's headache. This is much easier. So then at the end, you know how to save it in a graph data structure and get it, or how to save it in a relational database and still build this and process it. So, okay. Right. So they have given a lot of activities. Make sure you do these activities and check your answers with ChatGPT. Okay. Right. अब मैं कथा करने database object oriented. Okay. Excellent. This is just a summary of each. Okay. Motley. Right. අපි එකක් චුට්ටක් හයියෙන් go through කරමු. Summary of comparing each. Okay. Right. Handling relationships. So remember in relational databases, we used to handle relationship using foreign keys. Right. Using foreign keys. So, and in SQL, you can write joins. Inner join, outer joins, right? Left outer join, right outer join, full outer joins, and so on. And if it is many to many, you need a connecting table and create it as two one-to-many relationship. So then in relational databases also, we managed to map relation hierarchies, right? Using some type attributes. Remember the 3-table approach, 2-table approach, 1-table approach. හරි ඒවා ආයෙ අහන්න ගන්න නැහැ මෙතන හරි. ඒවා කරාට semester 2 වල. Right. So what is the best approach when it is overlapping and total, overlapping and partial, right? Then disjoint and partial, disjoint and total. Right. So that is relational databases. Of course, in relational databases, the operations are anyway handled by the programming side, okay? Programming sides, but we can even have a bit of stored procedures, triggers to do some programmatic things in even relational databases. But very rarely we use those, okay? So then we moved on to XML. Right. So it's follow hierarchy or tree structure. Okay. Tree structure. And it's a self-describing data because your tags describe your data. Even JSON is self-describing. Okay. So inherently keep an order, right? XML එකේ order එක maintain කරනවා නේද? First record, second record කියලා පේනවා නේද? Right. So student කියලා පළවෙනි student ගේ details එනවා ඊළඟ දෙවෙනි student. So there's an order top to bottom. Okay. So then the aggregate oriented, you have the major objects, so then they can be associated, then you have the aggregation from those major objects. Right. So it's sort of a not really, it's sort of a hierarchical as well, but at the same time, these things can get mixed together, so result in a graph. Okay, graph. Right. Right. Graph databases, save it as a set of graphs. Right. So this is another subtopic they have added. Aggregate oriented versus aggregate ignorant. Okay. So oriented means it's supported, ignorant means it doesn't support, it doesn't care. Okay. It doesn't care about aggregations. So this is aggregate is supported, so care about that. Okay. Right. So remember in semester 2, we discussed on databases materialized views. Materialized views means that view is already as a table. So that view is again table. You duplicate data. Okay. So if you want, you can have the similar concept in aggregate-oriented database also. That means you duplicate your data in multiple aggregates so that you speed up data retrieval. More storage, but speed up data retrieval. Okay. Right. And obviously, you know that in NoSQL, we respect less about the schema. That is why NoSQL is good for the semi-structured data, right? So that is obvious. Right. Right. Again, they talk about the materialized views. So materialized views are better when you have more read operations and you read data in different ways. But if you have more write options, that is bad because then you have to update multiple bases. Because materialized views means same data is duplicated and available in multiple structures. That is good for reading, but bad for writing because when you update, you need to update multiple bases. Same data is duplicated. Okay. Right, that's it. Right, so now you can take the past papers because past papers are available in Google Classroom. Okay. Last 3 years of past papers should be there. Not 3 years, I think more than 3 years. Yeah, more than 3 years. But some past papers are actually not semester 3 past papers. For example, these are all syllabus past papers, right? So first you concentrate on the new syllabus past papers, right? That is 2021, 22, 23. But when we say all syllabus, make sure you pick and choose questions related to your syllabus, because earlier the syllabus was much difficult, okay, much hard.
The part 2 paper is with the answer, no?
Sorry?
Part 2 paper,
Yeah,
it's
what is your
with the
question?
answer, not separately. Part 2
Yeah,
paper,
with the answers. Yeah, with the answers. Yeah, with the answers. Okay. Yeah. Right. So in the evening session, first we will do the last 3 past papers, second papers. Then we will move on to our web development topic. Right. So the evening session start at 7. Okay. Right. We stop at this point. Thank you.